All right, the topic is transformations. This is notes 19. Graph the function x squared. Use your graphing calculator to graph and compare the following to this parent function. Describe what happens to the graph. Okay, so in your graphing calculator, we've got x squared in there. If I hit graph, okay, we have the quadratic parent function. On this first example, I'm going to go ahead and graph the parent function, and I'm just going to use some basic critical points. Okay, I'm going to use these points on all of these graphs. 0 squared is 0, negative 1 squared is 1, 1 squared is 1, negative 2 squared is 4, and 2 squared is 4. Okay, I'm going to use those basic points for everything. So 0, 0, 1, 1, negative 1, 1, 2, 1, 2, 3, 4, negative 2, 1, 2, 3, 4. Okay, so this is my parent function. All right, the negative in front means I'm going to make the entire function negative. Let's go to the calculator. To see what that looks like, I'm going to put negative in front of the entire function. And then graph it. Okay, the entire graph was flipped. So using these points here, if every one of these points need to be negative, the 0 is going to stay the same. It's still going to, you can't make 0 negative. But instead of negative 1, positive 1, it's negative 1, negative 1. Okay, and then positive 1, negative 1. The 4s are both going to become negatives. Okay. So that's how it would look if you just put a negative in front of the entire graph. Okay, so all y, since f of x stands for y, that means negative y. Okay, so all your y's became negative. All right, on this next one, we're going to take and subtract 2 from every x value. Okay, let's see how that would look in the graph. I'm going to keep my parent function in there. Okay, there's your parent function, and then there's the new function. X minus 2 shifts your graph over to the right 2 spaces. Okay, if I look at the table, I can compare the values. Every x value was shifted over 2, and your y values changed. Okay? So the original parent function, 0, 0, 1, 1, negative 1, 1, okay? And then you're just going to take that, and every single value is going to come over to the left. Okay? Okay? So this is going to be a shift, to the right 2. Okay? X plus 2, how's that going to look? Go to y equals. The parent function, and then the graph is going to go to the left 2. Okay? So we're going to go ahead and graph the original. Okay? And then every single x value gets shifted over to the left. There we go. Okay, let's see how this graph looks here. The function plus 2. So I'm going to take the parentheses off. X squared the function plus 2. Okay, so your parent function is going to be shifted up 2 spaces. Okay, and that's how that graph would look. And then the function subtract 2. Graph that. So that's going to shift your whole function down 2 spaces. Okay, there's your parent function. And then there's the function minus 2. Are there any questions on that? Okay, on this next example, the 2 is being multiplied times the entire function. So let's see how that looks. 2 times x squared. Yeah, this whole example is using the parent function f of x equals x squared. So on this example, if we took the parent function x squared and multiplied it times 2, you can see here that it makes the graph more narrow. Okay? And if we compare those numbers that we had in the beginning, 0, 0, well, 2 times 0 is still 0. Okay, 1, 1, if you multiply 1 times 2, instead of going over 1, up 1, now we're going to go over 1, up 2. Okay, 2 squared was 4, 4 times 2, now we're going to go up to 8 instead of 4. So that's how it's making your graph more narrow. It's stretching up a lot quicker than it was before. Okay, so 0, 0, 1, 1. I'll just graph the parent function first. Okay, so when we multiply 2, every number on the y is going to be doubled. So 0 times 2 is still 0. 1 times 2 is 2. Okay, 2 squared is 4, but 4 times 2 is 8. So you can see that my graph is going to stretch up a lot quicker than the parent function did. So when you multiply your whole function by a whole number, it makes it more narrow. And the word they use to describe that is stretch. But what do you think is going to happen if I multiply my whole function by a number that's less than 1? If I use a fraction, it's going to get wider. Okay, it's going to stretch out wider. Okay, so let's be specific on our stretches. This one's going to stretch in the y direction because it's going to get really skinny. But this one here is going to stretch in the x direction. Okay, let's see how that looks when we graph it. There's the parent function, and then there's that one. So if you look at these same numbers over here, okay, in your chart, 0 squared was 0. If I divide that by, or if I multiply that by 1/2, I still get 0. Okay. Let me go ahead and graph the parent function first so we can compare to it. Okay, so 0, 0. All right. 1 squared was 1. 1 times 1/2 is 1/2, right? So instead of going over 1, up 1, we're going to go over 1, up halfway instead. So that's going to be the same thing here on this side. Okay, let's do the 2. 2 squared gave me 4. 4 times 1/2 is 2, so I'd go over 2, up 2. Okay, 4 squared is 16. 16 times 1/2 is 8. Okay, so over 4, up 8. So my graph is wider. So if you have a number on the outside of your function, it's going to give you a stretch of some kind. Okay, on these next two examples, and rather than multiplying the entire function by a number, we're going to multiply the x by a number and see what happens. So to graph this, okay, I'm going to put 2x inside parentheses and then graph it. Okay, there's my parent function. And look what happened to it. It makes it more narrow as well. If you look at your graph here, okay, let's compare the original parent function first. Okay, so that's the point 0, 0, 1, 1, 2, 4, 3, 9. Okay, this time we're taking all of our x's and multiplying them by 2. So 2 times 0 is still 0, and 0 squared is still 0, so we still have the point 0, 0. Okay? 2 times 1 is 2, okay? And 2 squared is 4. Okay, so 1, 2, 3, 4. Okay, x is not 2 here. X is 1. Okay, this number right here. So that's why it's coming in narrow. 2 times 2 is 4, and 4 squared is 16. So instead of going over 2 up 4, going over 2 up 16. Okay, for the function of 1/2 of x, okay, since the function is x squared, okay, we're going to take 1/2 of x, and when you do that, it's going to make your graph, your parabola wider. Okay, as you can see over here, you're not going up as fast. Okay, you're going up a lot slower. All right, describe what has happened to y equals x squared in the following graph. Okay, one thing that has happened to this graph, it flipped. And how do you make it flip? So negative. Okay, it also, the vertex is normally right here, and now it's up here. It went up 3, and it went over, and it went to the right 5. Okay, so the resulting function would be negative f of x minus 5 plus 3.